Okay, if we're given a tabular function and assuming that the transformation is a vertical stretch or compression, we want to create a table for a vertical compression. Now, determine the values of A and then multiply all the values or multiply all the output values by A. Now, in example 14, we're finding a vertical compression of a tabular function. A function f is given as table 10. We want to create a table for the function g of x, which is equal to 1/2 times f of x. Now, it's titled as a vertical compression. The reason why it's a vertical compression is because we're multiplying the function by 1/2. And again, going back to that definition, that is saying that A is in between 0 and 1, and that means that 1/2 is in between there. So now we know that this is a vertical compression. Now, the formula tells us that the output values of G are half of the output values of F with the same inputs. However, for example, we know that f of 4 is equal to 3. So let's take a look at this. That means that now our output values are going to change, but our input values are going to stay the same. Now, if we want to solve this, we know that if we look at the table here, we know that f of 2 has an output of 1. Now, g of x tells us that we need to take 1/2 and multiply it by f of x. So if we then change x to be 2, so g of 2 is going to equal 1/2 the output of f of 2. Well, the output of f of 2 is 1, and if we take 1/2 and multiply it by 1, that's going to give us 1/2. So now g of 2 is going to equal 1/2. Next, we have f of 4, which is equal to 3. So if we take g of x, which is equal to 1/2 of f of x. Now, if we change that to g of 4 now, it's going to equal 1/2 of f of 4. Recall that f of 4 has an output of 3. If we take 1/2 of that, then we get 3 over 2. So g of 4 is going to equal 3 over 2. Next, from our table, we have f of 6, which is equal to 7. Again, using this formula, this function, we get g of 6 is going to equal 1/2 of f of 6. Recall that f of 6 has an output of 7, so 7 times 1/2 is going to give you 7 over 2. And the last one, we have f of 8, which is equal to 11. So when we plug in g of 8, it's going to equal 1/2 of f of 8. We know that f of 8 has an output of 11, so 11 times 1/2 is equal to 11 over 2. So we do the same for all the other values. So now we have the same input, but it vertically compressed, because now our y values are smaller than the original values. So we get the outputs as 1/2, 3 over 2, 7 over 2, 11 over 2. So again, analysis, the result is that the function g of x has been compressed vertically by 1/2. Each output value is divided in half, so the graph is half the original height.